Hello and welcome to the Argos Advanced Training. My name is Ditas and I'll be leading the training today. The intended audience for this training is the Argos Data Block Designer and Argos Administrator. The prerequisites to this training are the Argos Report Viewer, the Argos Report Writer, and the Data Block Designer trainings. The goal is to demonstrate advanced techniques such as creating multiple forms and drill-down charts, creating OLAP cubes, and setting up API calls. We'll be covering the following objectives in this training: an overview of the Data Block Designer and Argos Administrator, how to add more forms to the dashboard and using those forms to create a drill-down chart, how to add and configure an OLAP cube, and how to set up a report API. All of the objectives we're covering today in this training only apply to the Data Block Designer and the Argos Administrator. However, there are a difference between the two roles. Now, in this table, notice that the Argos Administrator has access to more operations than the Data Block Designer. If you would like to see more information on the operations available for each user role, please see our in-product help. The first two topics I'd like to cover are multiple forms and charts. We'll take a look at how to create new forms in Argos and how they can be accessed. Argos allows you to use multiple forms within one data block if one form is not enough. In our example, you'll see how a separate form can be used to display the results in a chart. We'll also take a look at how to create a chart and how charts and forms can be used together to create a drill-down chart effect. Today, we'll be working with the address information data block, which is the same data block that you've seen in the previous trainings. So let's begin by opening Argos, and I'm logged in as an administrator. To add a new form to our data block, you would simply click on the blue plus sign on the top left of the Forms tab. So let's give the form a meaningful name, such as what this form will contain. And since this form will contain a chart of students' gender, I'll go ahead and name it Gender Chart. I've now created an additional form. Now I want all my forms to have a similar look, so I had created and saved a template with my background image, my logo, and my data block title into the library of objects. I can now retrieve that and save myself some time. So now that the base of my form is complete, I need a way to access this form from the main form. Now there's two ways that you can do this. You can use a tab or via an on-click event. I'll show you the tab method first. So to create a tab, you want to highlight the form that you're on from the Forms tab to make sure that you're on the right form, and then select the Properties tab. From the Properties tab, you will set the Is tab property to Yes. And then you can change the tab name to your preference. I'll call this Gender. Now I've already made the main form a tabbed form, so I can now move back and forth between the two forms. So I'll commit and test to see how the tabs turned out. Now notice the tabs in the upper left corner of the screen. The tab contains the form names, and clicking on that tab will open that form. Now the second method of accessing a form is with the use of an Objects on-click event. For this example, I'll use labels to essentially create a link. Now clicking on a label will activate that form, similar to how the tabs worked. So I'll start by adding a label to the Gender Chart form. I'll configure the label properties. I'll change the font color to white. Font size to 12, and then click OK. Alternatively, you can also set that here. Now I'll use this label to take us back to the main form, so I'll change the text property to main. You can type it directly here or click on the ellipses to bring up a box. So next, I'll configure the onClick property by clicking on the ellipses in the onClick property. I'll select Activate Form, click the blue plus sign to bring it over to the event list, and then in the form name dropdown, I'll select the main form. And to let my users know that this label is clickable, I'll change the cursor property to a hand point. So now the cursor will turn into a hand point when I hover over the main label, letting my users know that this is a clickable object. And now that we have a link to the main form, I'll create another label that tells the user what form they're currently on. I'll configure the text properties similar to how I did the main. So I'll change the color to white, size to 12, and this time I'll choose bold. I'll call this label Gender Chart. I have now created a navigational link on our forms. So we're now able to get to our main form by clicking on this main label that we've created. To get from our main form back to the gender chart form, I've already created a similar navigational link on the main form. So let's go ahead and commit and test and see how this worked out. Now here we can navigate to the gender chart form or the main form in two ways. We can click on the label, or you can click on the tab. So now that the gender chart form is ready to go, I'll add the chart. Now the chart that I'll be creating will use a different data set than the report query, so I will need to create a SQL variable to return the data. From the design window, I would click on the variable tab, and then click on the plus sign to add a variable to this list. I'll leave the SQL statement radio button selected, and then click OK. Now we could select the ruler and pencil icon to go into Visual Designer, but my SQL statement is easy enough that I can just type it into the SQL editor box. I'm actually going to just copy and paste it here to save myself some time. Now for this chart, the query will count the number of males and females from the table. There's a decode function to set the value of M as male and F as female, and anything other than M or F will be counted as unknown. Now the query will need to be validated before it can be used in the form, so I'll click OK, and then Yes to validate. Now I'll give the SQL variable a more meaningful name, such as gender count. Now I'll click on the pie chart icon on the toolbar to select the chart object. Holding the left mouse button will allow you to draw the chart's bounding box, or you can just left click to place the object on it, and then resize it later. Now you have two options for charting. There's Classic and there's Standard. Classic charts allow you to use the look and feel of previous versions of Argos, but you may see some differences between the client and web viewer applications. Now the standard chart has a more modern look that stays the same in the Argos client as it does in the Argos web viewer. Now in order to keep the look and feel of my charts the same in the client and in the web viewer, I'll choose the standard chart option. Now the series manager is what allows us to create and manage the series that's used in the chart. A series is a set of values that are grouped together for the purpose of displaying them in a meaningful way. The series section displays the available series, as well as its chart type and the associated data set. So let's start by clicking the blue plus sign to add a new series. Now the Data tab here is where you name the series, assign or create a data set, and specify what field will be used as the value and what field will be used as the label. I'll name this series Gender Series. I'm going to select Gender Count from the Data Set dropdown, which is a SQL that we just created previously. Now I'll use Count as a value and Gender as the label. The Type tab allows you to select the chart type. The default type is a bar chart, but there's other charts available such as pie. There's gauge, line, point, and area chart also available. Now depending on the chart type, there may be additional options. Now note that a tab called Bar Options will create when I add a bar chart. And here we see that we have the option to display the bar chart horizontally if you like. But for this example, I'm going to choose a pie chart. Now the Labels tab here is where you configure the label properties. Here you can choose the label style and whether or not the labels will be visible. I'll make the labels visible, and I think I'll leave the label style as value. Click Next, and this is a chart panel window. Here's where you can format the background panel of this chart. I'm just going to leave the default white background with no borders. Now the Chart Legend and Titles window allows you to configure where and how the legend and titles are displayed. So let's make the main title of the chart Gender Count. You can also change the font size here. And this completes the chart. Now the next thing that I want to do is change the variable name property of this chart to something more meaningful. So I'll change the name of this to parm for parameter, CHT for chart, and gender. So now let's commit and test to see how this chart looks. Now from here, if we go into the Gender tab, you can get to the Gender Chart form. And you'll see the pie chart that we just created. We see the count being displayed as a chart value and the gender as a label. So now I've shown you how to create multiple forms and how to create charts. So next, I'll show you how these two features can be combined to create the drill down effect. I want to be able to drill down into this pie chart that I just created so that when you click on a slice of this pie, a breakdown of the count will be displayed. So for my next example, I'll break the gender count by ethnicity. I'll need another SQL variable to create the ethnicity chart. So I'll create the new variable using the same method as before by adding a new SQL variable. And just like earlier, I'll enter in the query and I'll copy and paste it to save myself some time. Now this query will get a breakdown of the student count by ethnicity based on the gender selected from the pie chart. So I'll click OK, and then yes to validate. And I don't have to enter anything here in this parameter value to validate. So I'll click OK to continue, and click OK. And now I'd like to give the SQL variable a more meaningful name, such as ethnicity count. So now we need to add an additional form to hold the second graph. I've already created the additional form to save some time. And it was the same way that I created the gender chart form. And I named it Ethnicity Drill Down. Now, if you recall, we added the form template from the library of objects to our gender chart form, and I did the same thing here for that consistent look and feel. I also added the navigational labels in the same manner and simply changed the label properties. So now I'll create the new chart the same way that I did the first chart. Again, I'll use the standard chart option. I'll click on the blue plus sign, add a new series, and I'll name this one Ethnicity Series. I'll select the ethnicity count dataset from the dropdown. I'll use count as a value and ethnicity as a label. And this time, I'd like to use a bar chart. Now, to keep the consistent look and feel, I'll configure this chart the same way I did my previous chart. On the Labels tab, I'll set the label to visible and leave the label style as value as I did before. I'll leave the default background panel options and click Next. And for the main title of this chart, I'll name it Ethnicity Breakdown. And also change the font to size 18. I'll click Finish. And change the variable name to parm_CHT for chart and ethnicity. Now what I need to do is give the gender chart an on-click event. I'll do this the same way that I did for the navigational label. So I need to go to the gender chart form by selecting it from the Forms tab. I have to click on the chart object so I can configure the properties. And then on the ellipses, on the on-click property, we'll bring up the event editor. Now I want to configure the on-click event so that when a section of the pie chart is clicked, the ethnicity breakdown for that section is displayed. So to do this, I'll add the Activate form into the event list, and then select Ethnicity Drill Down from the Form Name drop-down list. And then click OK. So let's commit and test to see how everything looked. So let's go into the gender form, and if you click on male, you see the ethnicity breakdown for males. And if you go back and click on female, you'll see the breakdown for females. And the same for unknown. So next we're going to go over OLAP data cubes. Now OLAP, or Online Analytical Processing, is a specific way to represent statistical data for executives, specialists, and analysts. A popular definition is a million spreadsheets in a box. Now the key to OLAP is its ability to allow the end user to configure different views of the same data in an electronic spreadsheet format. So by moving rows and columns or clicking on them, the user makes the system perform calculations and show data in different aspects. Now let's go back into Argos. Now a new form is needed to hold the OLAP, which I've created ahead of time. I set it up like the other forms using the Library of Objects template, and I set the IsTab property to yes. And now to create the OLAP cube, you would click on the cube icon on the toolbar. And to create the OLAP cube on the form by clicking and holding down the mouse while forming a square. You'll see a blank OLAP cube on your dashboard, and double-clicking on it will open the OLAP Cube wizard. Now the first window of the Build OLAP Data Cube wizard is where you'll configure the main properties of your cube. So you would use the pane on the left side of the wizard to select the general, the totals, and the subtotals properties to configure. Under the general section we have the following options. We have supersaturated, which is used for advanced calculations. However, please note that enabling this option will require more memory. Exclude zeros from averages, eliminates entries that are zero from your average. You can hide empty columns and hide empty rows. You can show dimension and measure toolbars, and auto expand all column and all rows. Now please note that these options will also require additional resources. When enabling one of these options, it will prompt a warning message. So for example, if we enable auto expand all rows, it will warn us that enabling this feature may consume large amounts of resources. So for more information about these general options, please view our in-product help by pressing the F1 key. Now the totals section allows you to select the location of both the rows and column totals. Selecting none will hide the totals. In the subtotals tab, this section allows you to choose whether or not to show the subtotals and select their positioning. Now for this OLAP cube, I'm going to keep all of the default settings here and just click on Next. And here is where we will build our query. Now OLAP cubes are populated by one or more data sets. If your data is arranged in a true star schema, you can simply create your fact and dimension table queries and then link them when you configure the dimensions. Now if your data is not arranged in a star schema, it's typically best to simply create a single query that will contain all your measures and dimensions. For this example, I'm going to use only the fact table. However, if you would like to add more data sets to the OLAP cube, you can click on the blue plus sign at the very bottom left corner. I'll add a data set a little later to demonstrate. For the fact table, I have a query that I'll copy and paste to save some time here. For this example, I'll be displaying the same information as was on the chart that we created earlier, which is the number of males and females and the count of ethnicity. I'll go ahead and click on Next. Now this window is to configure the measures. The measures are the numeric items that you want to count, sum, average, or perform other calculations. So this screen allows you to pick the fields from the fact table that you want to measure, which is up here in the available fields. You can configure measure options such as display, calculation, and method format, and create calculated measures, which are derived from one or more fields from the fact table, and you can create a calculated measure by clicking on this calculator icon. I'll add a calculated measure a little bit later to demonstrate. So now let's go ahead and add the measures. All you need to do is drag and drop from the field, or you can double click on them. For this example, I only want to measure the gender. And I want to change the display name so it's easier for my users to read. So I'll change the display name from this to gender. Now for my method of calculation, I want to use count, as this will count the number of males and females. And I'm also going to change the display format. I want to remove the decimal points, so I'm going to remove the 00, so it just reads 0. And there's also the distinct option, which is to make sure that duplicates will only be counted once, but I'll just go ahead and leave that unchecked for now. And then click Next. Now this is the Configure Dimension area where you control how your measures are grouped. And there are 3 tabs, which are the initial locations of the dimensions. Now dimensions that are placed in the Available tab are dimensions that's available for use by the report writer, but they are not used as row or column dimensions at the start of the cube. To add the fields onto the Initial Location tab, you can double click on the field, or you can drag and drop it into the Dimension tab below. Now dimensions placed in this column tab will be default column dimensions in the cube. So I'll add gender here to the column tab. And I'll change the name to gender here for the display. And any dimensions that's placed in the row tab will be the default row dimensions in the cube. I'll add description and pin them to this row tab. I also want to change the names for these. Now you can also order the available column and row tab listings in alphabetical order if you like. And to use this feature, you would simply right-click in one of the initial location tabs and then choose the sort by A to Z. You can see display names have been changed in the preview of the OLAP cube on the right-hand side. Now in the middle, notice the other additional options. There are two options that specify where our data from that dimension is coming from. The data will come either from the fact table or from another data set. And there are also the default sort method for sorting options and forecasting, which allows you to compute feature trends using various methods. Now please note that most forecasting methods do require at least 3 data points. So I'm going to leave these default settings and then just click Next. And the last window of the OLAP Cube Wizard is where you can choose a style if you have one. Now select a style from the Library of Objects Explorer on the left side. These styles were created using the Library of Objects Manager from the main Argos interface. Now if you change the color theme property for the OLAP Cube, it will overwrite and remove the default theme. Now I'm going to use our eVision's development standard style for the OLAP. And then click Finish. And now we're done with the OLAP Cube setup. So I'm going to commit and run the dashboard to see the changes to the data block. So here's the OLAP cube, and you can see the different ethnicities and its count based on gender. Also notice that ethnicity is on the top and PITM is on the bottom. And this means that we can drill down ethnicity so we can see the PITMs that are part of the ethnicity group. So when we expand the ethnicity columns, you can see it's only showing PITMs and the count. Now it's difficult to determine who falls into the ethnicity based on the PITMs. It would be easier if we could actually see names instead. And also, some of the PITMs have 0 across the row. And this means that this person does not belong in this ethnicity. So this is a waste of space. So let's go back. Let's make additional changes so we can see the names instead of PITMs, and then exclude them if they don't belong in this ethnicity group. So I'll also add a calculated measure to show the percentage of all the ethnicities. Now to exclude the zeros from the OLAP cube, we can hide these values by enabling the Hide Empty Columns and Hide Empty Rows. If we want to display the actual names instead of the PITMs, there's 2 ways that we can do this. We can rewrite this query in the fact table to include the names, or we can create an additional data set that will pull in the names. For this example, we'll create a new data set. So to add a data set, you'll click on the blue plus sign, and I'll go ahead and rename this data set to name. Now I'm going to pull the PITM and then concatenate the first and last name from the sprite and table. Again, I'm going to copy and paste my query in the SQL window to save myself some time. So next I need to get to the dimensions and then change the sprite and PITM so it will show names instead of PITM. So in the row tab here, I'll click on PITM and change the display name from PITM to name. And now I want to choose from another data set. Now notice additional options will appear when I choose this. Now the data set contains all of the data sets that were created from the OLAP cube. I'll go ahead and choose name, which is the data set that I just created. Now the key field here is used to specify what field in the selected data set links the fact table to the selected dimension table. I'll select sprite and PITM here. And the data field specifies what field in the selected data set will be displayed when the cube is run. So I'll change this to the concatenated names. Now the parent field is used to specify what field in the selected data is considered the parent of the data field. Now this value can be left blank if there is no hierarchical value set. So I'll choose blank. Now I have to go back to the measures and create the calculated measure. I'll click on the calculator here. And to add a new measure, you click on the Add New Measure button. I'll name this %pop. And then click the green check. Now notice, when we created this new measure, the calculated formula populated with a baseline script where you can write your own calculated measure. On the bottom left, there is the available measures that list the measures that are available for the OLAP data cube based on how the cube was created. And to the right are the available views, which lists the different types of views or calculations that's available for you to use in the calculated formula. So I'm going to revise this script here. So I can get my percentage of the gender column. I'm going to go ahead and finish. And let's commit the changes. So let's run the dashboard. Now let's go back to the OLAP form and expand the group. Now notice that we see the names instead of the PIDMs, and we no longer see any names with zeros across the gender. And you can also see our calculated measure column displaying each ethnicity's percentage by gender. Now there are two additional options for OLAP cubes. There's saved OLAP settings and saved states. Now saved settings allows users to save the current settings of an OLAP cube. The saved settings include items such as the current dimensions, the measures, filtering, any custom formatting, column widths, etc., so that you can quickly return to the same cube view that you had previously. Now saved states allows you to save the data as it was at the time that the report was run, so it can be reproduced exactly as it was at that time. Now when you run the report, you will be prompted to select which saved state you would like to use. Now first I'd like to go over how to utilize the saved OLAP settings. Now to use the saved OLAP setting, first I'm going to move the dimensions. I'm going to expand gender. And now if I want to keep this setting, I would right-click on the OLAP cube. I would then go to Saved OLAP Settings, and then Save Current OLAP Settings. The Create New Saved Settings window will appear, and here's where you can create a new saved setting or overwrite an existing one. You would type in the name of this saved setting and add a description if you like. By checking the Share with Others users checkbox here, this saved setting will be available for other users to see. Now if this box is not checked, then this saved setting will only be available to you. So once you've entered in your name, you click OK to save this. And now let's see how this works. I'm going to close out of the dashboard and then run this again. So let me go back into the OLAP. Now notice that nothing is expanded and the dimensions are in its default locations. And now I'm going to load my save setting by right-clicking anywhere on this OLAP cube, hover over Saved OLAP Settings, and click on the name of the save setting that I had created earlier. And now you see the OLAP setting has been loaded. Now the option to pin a saved setting is also available. And pinning a saved OLAP setting allows you to designate a saved setting as a default that will be loaded when the dashboard first runs. To pin a saved OLAP setting, right-click on the OLAP cube, go to Save Settings, and then Manage OLAP Settings. Now the Manage Saved Settings window will appear, and here's where you can select an existing saved OLAP setting and then pin it by clicking on the pin icon. So let's select our saved setting, pin it, and click OK. And let's see how this works. I'm going to close out of the dashboard and run this again. And if we go over to the OLAP cube, notice that it's using the location that we specified in the saved OLAP pin setting. And now I'd like to go over saved states. Now, saved states can only be created through a schedule. To create the schedule, you would highlight the dashboard and select Schedule. First, let's deactivate this schedule, and then click on the Task tab. I'll select Saved Execution State, and then click on Add, and this will add the Saved Execution State to the Added Task section. And when we add the Saved Execution State task to the Added Task section, the Edit the Saved Execution State Task window appeared. So I'll keep the default settings here and just click OK. And notice that the schedule was created under the dashboard. So I'm going to test the schedule. So I have to go back in. I'm going to click on Test, and then Yes to continue. So this should finish quickly. And to view the saved state, you would run the dashboard. So let's go ahead and do that now. And if it's done correctly, you'll be prompted to select a saved execution state. Now you can choose a saved run state window. Here, you can select to either run the dashboard live, load it from a saved state from a file, or select the saved state to run. You also do have the ability to save a saved state to your file system. Our next topic is the Argos API. This is an optional module that enables the user to call Argos reports and/or schedules outside of the Argos software. Since the API can make the data available to a very wide audience via the web server, portal, or a third-party application, only an Argos administrator can enable a report to be available via the API. An API-enabled report can be executed through 3 different methods. One method is the HTTP GET request, which is much like a standard URL web page link. Another method of executing the report is via a post form in which the calling web page gathers any needed parameters. And lastly, there's an interactive method. When you run a report in interactive mode, the DataBlocks dashboard launches in a restricted version of the Argos Windows client on the user's machine. Now, reports can use all 3 methods, whereas a schedule can only use the post and get method. So I'll show only an example of a report API for this training. For the first example, let's create an API call using the GET request. So you click on the sample GET button, and this will copy the HTML code to your clipboard. Next, you want to paste it in a notepad and save it to a location of your choice as an HTML file. Now let's open this using a web browser. And notice that we have a link. Now when I click on this link, it will make the API call to Argos and it will generate the report. And here's the extract report. Now if you attended the Argos Report Writer training, Remember that we had added a variable for the comments onto the report. We can pass parameters to this comment variable using the get method. So let me show you how to do that. At the end of the link, you would add an ampersand, the name of the variable, parm underscore mm underscore comments, and then your comment. So let's save this and rerun it. And I'll click on the link to run the report. And notice now in the comment area, we have the phrase, "This is a test." Now the next example that I'd like to show you is the post method. So going back into Argos, let's go back to the API in the report and click on the sample post. Similar to the sample get button, it will prompt the user that the sample code is copied onto the clipboard. So next, let's open this API HTML file that had the API from the get call, and let's replace it with the post call. So I'll save this and run it in the browser. Notice that this time we have a button. Now when we click on this button, it will execute the API call to Argos and generate the report. Now you can also pass parameters similar to the get method, but it is handled a little bit differently. So let me show you how to do that. Now underneath, you'll see all inputs here. Now we need to add a new form object here and then name that object with the same name as the variable. So for example, to add the comments variable, I want to add a new input underneath all inputs here. So I'm going to add the following. Add the input type will equal text. And the name will equal my parameter name, parm underscore mm underscore comments. Now let's save this. And run this in Chrome. Now notice we have an edit box for the comments variable, and any text that's written in this edit box will be passed as an argument for the comments variable. So let's put the same comment, "This is a test," and then click on the button. Again, here's our report, and notice that we have the text, "This is a test," under the comments section. Now the last example I'm going to show you for the API is the interactive method. Now remember, this method is only available for report APIs. Now the interactive mode allows you to call any Argos report or a dashboard from a portal, a web page, or third-party applications by running a restricted version of the Argos client on the user's computer. So this means a user must be able to install software on their computer to use a report in interactive mode. Now please note, Mac PCs will not be able to execute an API call. So now, back in Argos, let's click on the Sample Interactive button. So let's paste this into our HTML file. Let's save and run. So I'll click on the link, and this will bring up the client. And now we can select our parameters in the dashboard and execute the report. And there it is. Now we also have the Argos Web Viewer API. The Web Viewer API gives users a way to embed Argos dashboards into another web page or a third-party application or portal. For this training, we won't be going over how to set up the Argos Web Viewer API. However, we do have documentation, and it's called Accessing the Web View API, and it is available in our community support. We also have the Argos Web Viewer API. The Web Viewer API gives users a way to embed Argos reports and dashboards into another web page or third-party application or portal. For this training session, we won't be going over how to set up the Argos Web Viewer API. However, we do have documentation, and it's called Accessing the Web View API, and it is available in our support community. We also have the Argos Data Block Connector. The Argos Data Block Connector API is an optional module that provides a way to load the results of an Argos report query into third-party applications and business intelligence tools. It uses a script to pass parameters into maps and then retrieves the data via a RESTful API. The results of the report query are returned in JSON format to the calling application. For this training session, we won't be going over how to set up Argos Data Block Connector API. However, we do have documentation, and it's called the Argos Data Block Connector Implementation Guide, and it is available in our support community. And lastly, there is the Cloud Connector. The Cloud Connector is a data connection that provides a way for you to load data from third-party web applications into Argos or other Maps applications. With the Cloud Connector, you can connect to any data source that provides a public-facing RESTful API. For this training session, we won't be going over how to set up the Cloud Connector. However, we do have documentation, and it can be found in our Maps in Product Help under Data Connections. And we've come to the end of the training. Thank you everyone for watching, and have a great day.